Welcome to Unlocking LaTeX Graphics. This channel features tutorials on using TikZ and PDF plots. I'm Tammy Kolda, an applied mathematician, and I've been using these tools for a long time. I hope to make them more accessible to you. Today I'll talk about drawing matrix equations in TikZ. It can be useful to create such drawings to show the shape and structure of the matrices. There are a lot of ways to do this. These are basically just rectangles. But I'm going to show you my preferred method, which uses TikZ nodes and a custom matrix style. We will use several TikZ features, including node position, node anchors, and coordinate calculations. I'm also going to use something that I don't think I've shown you before, and that is node labels. These place a label in relationship to the node, and it basically creates a new node for you, but in a much simpler way than creating it manually. I'll show you when we get there. I hope you find all this useful. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Before we create our matrix equations, let's set up the document preamble. The LaTeX package called Full Page sets the margins so that more of the page is used than is the default for the article class. The package parskip replaces paragraph indents with vertical space between paragraphs. And the hyperref package is used to create hyperlinks. And here I'm using it to link back to the YouTube channel. The key package, of course, is TikZ, which is the main package you need to recreate what we're doing here today. We're also using the positioning library to help with placing nodes relative to each other. Let's start by drawing a basic linear system equation, AX equals B. We'll use the TikZ picture environment to create our drawing canvas. So let me paste that here and scroll it up and compile. So far we have nothing, so all it shows is the section title. Next, I'm going to define a custom TikZ style for matrices. I'm going to place that in the optional arguments to the TikZ picture. The style is called matrix, and it accepts two arguments, which we will use to specify the height and width, respectively, in centimeters, so that's what I'm using here. Normally, to define a style, we just say style equals open curly brace and proceed from there. This time, I'm using a special key of style and args, and then I'm putting the number of arguments in the first set of curly braces, and then the definition of the style follows. Here, I'm using number 1 and number 2 with the number sign for the first and second arguments, respectively. So that's how I'm going to pass in the height and the width. It's also important, since we're drawing a matrix, to draw the outside. I'm going to go ahead and say we're going to draw it in blue. I'll also set the line style to be thick and the node font to be large with a capital L. I'll link in the show notes to prior videos that explain how to create custom TikZ styles in more detail. Now let's draw our first matrix. I use the matrix style that we just defined and pass in 4 by 4 as the size. I set the node contents to be a math boldface A, and we get the result over here. Next, we'll add the vector X to the right of the matrix A. I'm using the positioning library to help with this, and I'll link to a prior video on that in the show notes. I use the same matrix style as before, but this time I set the width to 0, which means that its width will be just wide enough to hold its contents. I also use right equals 2 millimeters. That's the positioning library to set the location. Next, I'll add the equal sign to the right of the vector X. Observe here that I'm making the offset 0 millimeters to the right of X because the node actually has horizontal space around it. In fact, you can see there's a little bit of spacing. If I put draw equals red into the node characteristics, we can see the little box with that extra space. That's from something called inner separation, and I'll link to a prior video on this automatic padding in the show notes. I also set the font to be large and bold math so it would match the other elements of our picture. Now let me go ahead and take out that draw equals red, and then I'll add our next vector, which is B, to the right of the equal sign. I'm using, again, that 0 millimeter of horizontal space to the right of the equal sign. This again takes advantage of the automatic horizontal padding. And again, I've used the width 0 because it will automatically size to fit the letter B. One minor annoyance here is that the letter X is actually not quite aligned with the A and B. So for example, if I paste here a line that starts at a.based_west, so this base west is a special anchor on the node that is aligned with the baseline of the text. And so you can see that X is just a bit higher than the other letters. I'm not going to show how to fix that here. I have another video I'm planning that shows how to do this. However, there's an entirely different approach to place the letters in an entirely different place, which I'll show in the subsequent examples. Let me comment at this line and then we'll continue. Now let's move on to a more advanced drawing of a low-rank matrix factorization. We'll build this up step by step, starting with a new matrix style and then adding each matrix in the factorization one at a time. First, let's define a new matrix style for this section. Notice that we're including fill equals dot exclamation point 10 directly in the matrix style. So the matrices will all have a light fill color by default, depending on whatever coloring we use. I'll also set the anchor to be the northwest corner of the matrix instead of the default center. This will help us later when we want to align the tops of matrices in some of the equations. Now we'll go ahead and paste a picture that draws us a 4x3 matrix using this style that we just defined here. And I'll remind you that when we define it inside TikZ set, it's available for the rest of the document. This matrix I put as blue. It's critical that blue is before matrix so that the color is used for the draw and the fill. Let me go ahead and compile this so you can see what it looks like. So far, there's no text label for the matrix because I left the node contents empty. Instead of adding text as contents inside of the matrix, I'm going to use that special node option I mentioned at the beginning called label. This goes inside the square braces. So I'll add a comma here and then I'll put label equals math boldface X and recompile. This automatically places a label. By default, it goes above the node. If there's interest, I can do another video on these special node labels. Let me know in the comments. We can specify the style of the label by setting the special every label style. So here I'm going to say that every label should use the large font size. When I recompile, the font is larger. Now I'll add a style to be used for the equal sign that I'll call EQN, short for equation. It sets the font to be large and bold math, and it says it should be positioned to the right of the specified coordinate. Now I can use that style to add the equal sign to the right of the matrix X. So I go down here and I place that node, and it's automatically to the right because of the EQN style, and I get that equal sign where I want it. Now let's add a 4x2 red matrix A to the right of the equal sign. Because I set the anchor to be the northwest corner of the matrix class, I have to align the top of A with the top of X and the left side of A with the right side of the equal sign. To do this, I'm using special syntax. The bar dash syntax between two coordinates means to take the X coordinate from the first and the Y coordinate from the second. I'll link in the show notes to a prior video on coordinate calculation that explains this in more detail. Finally, we're going to add a 2x3 orange matrix to the right of the A matrix. We specify its location as the northeast of A. However, we also add a small horizontal space of 2 millimeters to separate it a bit using this X shift option. Let's move on to the economy singular value decomposition, or SVD, as we know it in the linear algebra industry. Here's a picture of what it should look like. I'm flashing that up. And then here's some code. We're using the same matrix style as before. And the main thing I want to show you is how to make sigma not be filled in, but instead just have a diagonal, because in the SVD, this middle matrix is a diagonal matrix. Let's fix the sigma matrix. First, I want to set its fill to be none. And I do this after specifying the matrix type, because that sets the fill. And now I'm going to override what it said by saying fill equals none. After that, I can draw in that diagonal. So I'm just using the plain old draw command, using the same color, setting it to be ultra thick, and starting in the northwest corner of the S node and going down to the southeast corner. Now let's show one more matrix decomposition just for fun. I'm going to do something called the QR decomposition. I'll start by pasting the code for the basic structure with all the matrices in place. I've already set the fill of R equal to none, so it's ready for the next step. Now let's add the upper triangular part of the R matrix. We do that again with the draw command, but this time we're also going to add a fill. We'll start in the northwest corner of R, go to the northeast, the southeast, and then cycle. We'll close that, and then it can be filled. So when I recompile that, we see our upper triangular R matrix. One thing that you may notice here is that the labels are not perfectly aligned. The Q here is higher than the X and the R. To fix this, we can adjust the every label style to set the anchor to be the base of the node rather than the south point of the node. So to do that, I'm going to paste an option here, and it's going to modify the every label style that we've already defined above. That aligns them to the base of each label, but now they're too low. To fix this, we're going to go ahead and do a Y shift of 3 PT inside the curly braces for the every label. And now they've shifted up so that they are no longer overlapping the nodes. I hope you enjoyed today's episode on drawing matrix equations in TikZ. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TikZ or PGF plots questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.